Hello, welcome to the video. Today we're going to be looking at what is going on with this bloody PAL, GAL, NTSC, Kawari, Kung Fu Flash fuck up that we had in the other video. So, for a quick recap, I get a Kawari, I build a 66 clone and a 466 clone, and yeah, this is the beastie here. And as we can see, Ghostbusters shits itself when you try and start the game. So did Fix It Felix. Now if you go back and have a look at the PAL NTSC video, you'll see exactly what's going on. So I said at the end of that video I suspected a timing problem. And I went on to Discord, and the creator of BMC64 and the Kawari, Randy Rossi, he reached out and said, I don't think it's the Kawari, I think the PLA is a bit fucked. So yeah, how do we go about testing this? Because these GAL PLAs, they're supposed to be the absolute shit. They're meant to be bang on, super compatible. Yeah, so I built a few of these, and I built a whole batch, and out of the whole batch 7 of them told me to go fuck myself. One of them actually worked okay, and it coincidentally is one on a green PCB. Not that that's any bearing on this, but yeah, so I used the same batch of chips from China, the same everything, and only one worked properly. But the worst bit about it is, and check this out, if we fire this up, this is the junker by the way, I desoldered the PLA yesterday, and just so that I could piss around with it, and well, I'm not too bothered if it, you know, dies. So if we fire this up and we get another game, whatever, I've just chose that one at random. Yeah, look at that. You can see it's working. Now I've got the scope going as well, and that's why you've got all this shit in the machine going on. So let me just put this back to Ghostbusters. Yeah, all looks okay. Nothing. It's absolutely just fucked off for the duration. So I've hooked up scope to the OBS by the way, so I'll overlay this on the screen so that as I'm explaining it you can see what I'm about to say. So I'm thinking to myself, what's going on here? Because the games work, some games don't work. It just, you know, how can a PLA half work? So my first thought was that the PLA itself was causing a timing issue, and I still stick to that, as I'm about to explain. The way the Commodore 64 works is that the CPU doesn't control everything on the bus. The VIC does. And I know that might sound a bit strange, but the VIC actually, it has more to do than the CPU. Now, so the VIC creates a system clock for the CPU, and on the low part of the clock cycle, which let's just say it is 1 megahertz for now, right? So for the first half of that, the VIC's got hold of it, and it's got access to the entire bus. So whatever the VIC says goes, and then the VIC says, well, I've done my shit, CPU, you can have what's left. Now this leads to a point on the screen where sometimes the VIC takes a bit longer to do some stuff, and that's called a bad line, and that's when certain amounts of sprites need to be updated, and the VIC says, well, fuck you CPU, I've got a bit more to do, so you'll have to wait. Anyway, so I'm thinking to myself, what is going on with this PLA? Now the PLA sends out the chip select signals to all the different chips, but it does something else as well. It acts as a delay line for the CAS, and this is what first I thought was the problem. So let's power this up, just so that you can see what I'm saying on the screen. So when you activate DRAM, you have what's called a CAS and a RAS, and that's a column address strobe and a row address strobe. Now, what these do is they allow you to latch the data. Now, in the Commodore 64, it's a little more complicated because you've only got 8 chips, so you've got 8 data lines, and the chips are all connected in parallel. So you need to control the 16 bits from the bus into 8 bits for the RAM. So you need to latch that through the 257 chips, and that's done on the column address strobe. And one of the designers of the 64 was an absolute genius, because he thought, you know what, these 256 chips have got what's called a propagation delay, and it takes time to get what's going in to what's going out. And if you look at the data sheet, it puts it down in the order of around 10 to 12 nanoseconds, something like that. And that's a maximum value. But my point is this, that if you present your shit to the chips before the data is actually there, you're going to get dodgy readings. And that's what I thought was going on. So I thought, it's not really affecting the CAS line properly, and we've got a bit of a fucking problem, as some of the games are crashing. So on the screen at the moment you can see a yellow and a pink trace, and the yellow trace is, let's have a look, that is going to blah blah blah, the VIC2 output. So that is the CAS line. Now when it comes out, the pink one is the RAS line, and I've got it triggered off the other one, but the difference on the screen is saying that it is in the order of 8 to 10 nanoseconds. So if you look at the bottom of the screen, you can see the slew, or skew rather, it's a bit variable because it's having to sample it. So yeah, it's in the region of 8 to 10 nanoseconds, and that's, the delay is long enough for the 257 chips to latch the data, present the right data to the RAM chips and say, right, get it. So you think, okay, alright, there's nothing fucking wrong there then. So this is with the Gal PLA right now, and you think, oh yeah, it don't look too bad, it's about right. So let's whip that PLA out, drop in the desoldered one, which is actually good. It wasn't, I just dropped it. There we go. Now what you're seeing now is exactly the same thing. The timings are the same, pretty much. Oh look, the game starts. So with a real PLA, it works. With the Gal PLA, it says bollocks. So I thought, what is this about? So I shall just switch over and okay, so here we are back again, and I've switched it all over to the other 2 channels now. I could leave all 4 on the screen, but it's going to get a bit congested on the scope, so I've just switched them over and turned off the first 2, because now we're going to be looking at the chip select signal for the SID, and this is where I suspect the problem lies. So if we turn on the standard PLA, stock PLA, you can see the green trace is the 1 megahertz clock signal. Now the blue trace, there we go. So the blue trace is the chip select signal. Let's just turn that down. We don't need to be hearing all that. I've heard that about 50 times this morning already. So, yeah, so the green one is the clock signal. We can see full well what it is, what it's doing, and the values for the trace are set up on the right. So you don't need to be a genius to work out the frequency is 980 kilohertz or 0.98 megahertz. So we're talking PAL. It's absolutely clock on, right? So the green is the clock. The blue is the chip select signal that activates the SID. Now this is on the stock PLA, and you can see that that blue line keeps dropping. I don't know how well it will come out on the video, but you can see that it keeps dipping down, and it's only ever active, you can see the spike of it going down in the low portion of the clock. I think that's right. It's a bit hard to see because it's updating on the screen very quickly. But either way, you can see it's working, the 64 is working, everything's doing what it should be doing. What the hell is going on? So, let's just swap back to the shit PLA. I've done this so many times now. There we go. So we put that in. Now while it's on this screen here, you can see the chip select is still being toggled. There's still some activity there. But when you go to start the game, oh my god, it's lost its crumpets. The blue line has just fucked off. Now it's active low on the blue line, so when it's pulled low, that's when the SID is active. And as you can see, it doesn't get pulled low anymore. Hence, the whole fucking thing is locked up. But it gets better. Let's just extract this one. This is another one from the same batch, just on a green PCB. So we turn that off. There we go. So we're back to this point. Look at that. And now it's working. So some of the chips that are used in this, the 25 nanosecond PLA PAL chips, or GALs, GALs, they seem to be wonky as fuck. Because I've got a whole handful of these that don't fucking work. I've tried reprogramming the chip in the programmer. It's an actual timing issue with the GAL itself. I'm sure it is. But this is the root cause to it. But it works enough for some games to actually function, which is really bizarre. So let's just fire up a different game. Now, I haven't tried this before this video, so if we go to Fix It Felix, that was another one that was fucked. There we go. So it does this bit. Oh bollocks, it's going to need a joystick in it. It's always the way. Gonna wreck it. Yeah, already wrecked it. So I have to go for this bloody intro. So I've left the scope going. You can see that the sound's playing, and you know, it's the SID is working its tits off as it should be. There we go. And it's working. Now, let's transfer back to El Shito. And I suspect what we're going to see is the chip select for the SID fuck all the way off. Let's go through this again. come on. Remove my stump. Remove my PLA. There. And it's frozen. And as you can see, the activity has completely stopped. So, where does this leave us all? Well, realistically, I think this is... I thought this was a viable PLA replacement, and I've ordered some 15 nanosecond chips to replace them. But I'm still going to be absolutely wary as fuck about these $3 PLA things, or 20 V8 PLAs, or whatever they're called in there now. But I thought they were the most accurate, but yeah, I've lost a lot of faith in them now. So I'm actually going to go on at Retroleum in a minute and order a Plankton. They're supposed to be pretty good. Yeah, let's just drop that back out. Drop the actual PLA back in. Yeah, there we go. So what I'm going to do, I think, is I'm going to reprogram with 15 nanosecond chips when they arrive. They're coming from China, so it could be a bloody month. And then I'm going to try that. But I am really wary of them, to be honest. You know, this is... I didn't expect this at all. It's not the... I don't think it's the logic in the chip that is at fault. I think the chip itself... yeah, that's wobbly as anything. It straight in, look at that. No problem. So, yeah, so back to this whole thing. It's not the Kung Fu Flash, because I've actually loaded it off a 1581, and that does the same thing, because I ruled that out as well. The Quarry is an absolutely fantastic bit of kit. I completely recommend that to anyone. That has been brilliant. Having the ability to swap between PAL and NTSC is really, really nice. And when I go to do the 466 build 3 video, I'll give you a proper rundown. That's just fantastic bit of kit. As is the One Load 64 collection. So it's not the files that are at fault. It's not the Quarry at fault. And I've got to make that completely crystal clear. It's, yeah, shitty chips in these PLAs that were at fault. So, yeah, there's not a lot more to say on that. I'm going to say check out 8-bit Retro ReFix. I believe the 64 and ZX Spectrum giveaway has just come to an end, and yeah, the results are due Monday, I think, Tuesday, something like that. Yeah, check out his videos. He's got some good stuff over there, and thanks for watching.